Okay, one uranium atom weighs 3.95 times 10 to the minus 22 grams. Estimate the number of uranium atoms in 1 kilogram. Right, this is a non-calculator paper, so you are not allowed to reach for your calculator. So how are we going to do this? Well, what would it be, okay, if we were allowed to use a calculator? It would be, we have 1 kilogram, right? 1 kilogram of uranium, and it's got loads and loads of uranium, well, it's made up of loads and loads of uranium atoms. So if each one of these atoms weighs that much, we would divide the 1 kilogram, okay, which is 1,000 grams. So 1 kg is 1,000 grams. So let's put it in the same unit. So 1,000 grams divided by 3.95 times 10 to the minus 22 grams, okay? You don't need to include the unit. Grams on the top, grams on the bottom cancel. It's just 1,000 divided by 3.95 times 10 to the minus 22. If we put that into the calculator, that would tell us the exact number of atoms in this kilogram of uranium. But we don't have calculators, so it's an estimate. Notice that 3.95 is very close to 4. So that's what we're going to focus on. If that were 4, we could do this without a calculator and we'd still get an answer very close to the correct answer, which is that. So that's the approximation we're going to make. We're going to do 1,000 divided by 4 times 10 to the minus 22. Okay? That's much easier. And that, like I say, will give an answer very close to the true answer, because 3.95 is very close to 4. So that's what you have to do. Now, how do we do this without a calculator? Well, firstly, we've got 10 to the minus 22 on the bottom. So let's move that to the top. So that's the same as 1,000. 10 to the minus 20 on the bottom is the same as 10 to the 22 on the top. Okay? And we're still left with a 4 on the bottom. Okay, good. So next, we leave the 10 to the 22 alone, and we've got 1,000 divided by 4, which is 250. So that's the same as 250 times 10 to the 22. So we're pretty close now, but this is in standard form, and we're going to give the answer in standard form, but we're not quite finished, because in standard form you need 1 digit, then the decimal point, and then whatever, okay? At the moment, the decimal point is there. That's the same as 250.0. So we need to move this decimal point 2 places. So we're going to write it as 2.5 times 10 to the something. Now, that's 250, and we've turned it into 2.5. By moving the decimal point 2 places, we've made it 100 times smaller. So for this number to be the same as that, we need to make this 100 times bigger. 10 to the 22 times 100 is the same as 10 to the 22 times 10 to the 2, which is 10 to the 24. Okay? And that is the final answer. That's the estimate for the number of uranium atoms in 1 kilogram. Is it a sensible answer? Quick check. Yes, it is. A kilogram is roughly like a lump you could hold in your hand, okay? And an atom, as I'm sure you know, is very, very small. So you'd expect a very large number in a kilogram of uranium. So it's correct, okay? Now, the last part of this question, it wants you to say whether this is an underestimate or an overestimate of the true value, okay? Here's the true value, right? And here is our estimate. Which is bigger? Well, the true value, it was 1,000 divided by 3.95. The estimate was 1,000 divided by 4. The smaller the number on the bottom, in other words, the denominator, the larger the fraction. Okay? So 3.95 is smaller than 4, which means this number is bigger than our estimate. So the true value is bigger, so the estimate is an underestimate. Okay? Because in the estimate, the denominator was bigger than true value, making the whole thing smaller. Okay? And that's it. I'll just go over that last point one more time. If you have, for example, a half, okay? Half is 0.5. Let's make, so there's the numerator, the 1, and the denominator is 2. Let's make the denominator, leave the numerator the same, we'll make the denominator twice as big. When we make the denominator bigger, what happens to the whole thing? Well, a half is bigger than a quarter, so we've made the whole thing smaller. Okay? A quarter is 0.25. So you can see, as if you leave the numerator, the number on top, the same, make the denominator bigger, you make the whole thing smaller. And that's why it's an underestimate. Thank you for watching. I hope you found this video helpful. If you did, please click the like button, and it would be a massive help if you could subscribe. It would also be amazing if you could support me on Patreon. All the papers and everything are on my website, drjem.com, and I'm also on social media. Thank you.